We got 3.
Yeah, how many have I not done? 2. I've not done 2. So then it's time to do then. Okay, so we'll start with the homework then. Yeah. Well, that's what they say. I have to believe them. What 2? Let's have a look.
Yes.
The last 2, not the next 2. Interesting. Electric field, potential, and magnetic field. Yeah?
Didn't you?
Did I?
I don't know.
You finished the EQ, the dipole electric field strength.
I didn't do this. I know I didn't do this.
Yeah, you didn't do
There's a mistake in this one here. I know that. Okay. And then the next one is the same. Magnetic fields. Yeah? Yeah. Okay, so let's start with this one. Convert 2.5 electron volts into joules. So question 1, 2.5 electron volts equals open up the calculator. It'll be 2.5 times E joules, which is going to be some numbers. What is it?
4.0.
Yeah, we're okay with that?
Yeah.
Yeah. 2. 1.5 nanojoules into electron volts. So 1.5 nanojoules would equal 1.5 times 10 to the minus 9 over E electron volts. Let's bash that into the old calculator.
0.
Quite a lot, isn't it? Ah, no. Which is 9.36 giga electron volts. Yeah? Okay, that is 2. Now on to 3. Yeah? Problem? Way? Question? Did I? No. 9 is giga.
9 giga.
6 is mega. Yeah. Okay?
It's okay.
Or maybe it's okay for you. Is it okay for you? She'll tell me if it's okay for her. Continue. Right. What is the potential energy of a proton which is equal distance between 2 parallel plates separated 1 millimeter with a potential difference of 9 volts? So you've got a plate. This here is 1 millimeter, and there's 9 volts here and here. Okay. And you've got a proton here, and its height is half a millimeter, and its potential energy, it's not quite MGH, it's QED, or QEH if you want. So it's a proton, right? So that's going to be E, and then the E is V over D, where this D is the 1 millimeter, and this H is half a millimeter, and this is 9, isn't it? Yeah. So that's 9. That's a millimeter half a millimeter, I think it's
This
4.5, yeah?
This one.
1 millimeter.
Yeah.
Yeah, that's 1 millimeter, and that's half a millimeter. Yeah. And that's 9, and that's E. Yeah, so the answer is 4.5 electron volts.
You calculate in your brain.
Yes.
Now.
Yes.
Directly.
Yes. Because a half over 1 is a half. A half times 9 is 4.5. And to change this into EV, I have to divide by E. So 4.5 electron volts is the answer.
Sure, can't I just use the QV to charge it for
That is only when the proton is here. Begins its journey here. Not in this case. Okay. Can you write that one down if you have trouble getting it? Yeah? Oh, I'm still missing I'm correcting the essays, and I'm missing a cover sheet. Was it you? Somebody didn't give me a cover sheet on their physics essay. Was it you? Did you upload it? You did?
How did you know that?
Well, I don't have it. Can you email it to me? Your cover sheet. Thank you. And then once I'm nearly finished correcting your essays. I told you last week.
For essay.
Oh, for essay?
Yeah.
Oh yeah, I'll tell you this week. No, I'm not here on Friday. Might be Monday. Your physics exam results are on the notice board. You know that, don't you?
Yeah, check.
Yes. Okay. I'll put your essay on the notice board.
Monday. Next Monday.
If it's
Probably.
black, can you not tell?
The essays were actually quite good compared to other years.
Other years.
average around
Average is quite good. I don't remember.
possible.
Definitely, very much so, yeah.
Every can be good.
Huh?
Is that
I don't know if it's A. Well, no, actually, no, I think I gave a couple of people an A. Yeah.
Is there an A star?
Oh,
No.
oh, come on.
You said definitely is good.
Maybe 1.
One.
Maybe.
One.
Maybe. It's not you, though.
Yeah. I know that.
Alright, number 4. How fast will an electron be travelling if it leaves a negative plate and strikes a positive plate 2 centimeters away, potential difference of 12 volts. So what you've got here is, well, I'll draw it vertically for a change. You've got a plate, and an electron, and it fires across here, and I want to know what's V here. Well, this is just our potential energy equals kinetic energy, right?
Yeah.
So we just have a QV equals a half mv squared. Yeah? So that means V is equal to 2QV over m square root. So if I take it out here and just put that in, square root 2 E, and what's my voltage? 12 volts. And it's, I say electron, wasn't it?
Yeah.
2,054 kilometers per second. Quite fast. Is that okay?
Yeah.
Yeah. The next one. How long would it take for a proton to travel from the positive to the negative if they're 1 millimeter apart and the 25 volts? Yeah? So, you actually realize it's kind of the same picture, isn't it? except this time it's just a proton, but not that that makes any difference. In fact, what is the only difference here? This is 25 volts. So I could actually use this formula again. U is 0, V is, and I just need to change, oh no, actually I have to change another thing in the formula. Oh, come on, go back. There we go. What else do I need to change? The mass, isn't it? It's mass of proton, and it's not 12, it's now 25. So because that's bigger, this should be smaller. Yeah, 69,206 meters per second. The A we don't know, the T we don't know, and the S we do know now. It's a millimeter. And what did I want? The T, wasn't it? So what would be the best formula to use here? S equals?
UT plus R.
No. S equals U plus V over 2 times T. So the U is 0, so the T is 2S over V. Okay, so that would be 2S over V. .9 nanoseconds.
Question.
Yes.
Why can't we say QV is the potential energy? Why can't we write W like work done equal to distance over time?
Work done is distance over time.
QV is potential energy.
Correct.
And potential energy isn't it work,
Correct.
which is equal to distance over time?
Not distance over time.
X distance.
Force times distance.
Yeah.
Oh,
Question answered?
yes.
Okay. Right.
The proton is accelerating.
It is, yeah. Yeah. Okay. Next one. The hard one at the end. Okay. Can I do the last one? Or you need a minute? Take your time. Yeah.
Are all these formulas given in the formula book? Like the Q, E, H?
Formula book's on Moodle. I'm not sure if this one's in it. I think it is. I don't know. I just don't know. It's probably easier just to remember it.
What's the role of the formula book? What's the role of the formula book?
What do you mean, the rule?
Role.
The row.
The role?
Yeah. In exam.
Give you formulas.
It's hard to find that formula in this formula book.
Don't get a formula book. We want a formula book. Do get a formula book. Too hard to use a formula book. Like, give me a break. Alright. Can I do the last one now? Yep. The last one was quite hard, and there was a mistake in my question, as I was saying last time. So what I wanted was like a picture like this. This is positive, this is negative, and what you have here is an electron which is fired. It just about misses that plate and comes back down. This angle here is 45 degrees, and it's fired at 1,000 meters per second, and the distance between the plates here is 10 centimeters. And my question is, what's the voltage? Right, so yeah, quite hard. Let's have a look. So this one here is 1,000 cos 45.
Yeah.
And this one here is 1,000 sine 45. Let's look at the vertical. So, let's look vertical. U is 1000 over root 2. V, what's V? No, if we're looking here, 0. A, we don't know. T, we don't know. S, we do know. 0.1. Now the A is kind of interesting, because if you were to look here, there's obviously a force. So Newton said F equals ma. So A equals F over m. Do we know the m? We do. Do we know the F? We don't. But we could know the F.
Yeah.
Could we?
Yeah. No. The formula.
Well, the formula, it's QE.
Yeah.
And could we know the Q? We could. And could we know the M? We could. But could we know the E?
Yeah.
We could, because it's V over D. So this is QV over MD. So whatever answer I get for A here, I can say it's equal to that. So let's get the A. What formula best gives me the A?
That 2AS equal
V squared equals
yeah,
U squared,
yeah,
is it?
yeah.
V squared equals U squared, 1, 2, 3, 4, 5, 6. V squared equals U squared plus 2A.
Why you?
Yes.
Oh,
So that means the A will be, how many have I got? 6 zeros here. 500 over 0.2. So that's 2500. I hope. I think I have that right. 2.5 times 10 to the 6 meters per second squared. I hope. That's supposed to equal QV over MD. Because we just worked out the A over here as well, using the formula. So it means that V, which I'm looking for, is 2.5 times 10 to the 6 times the mass of the electron times 0.10 over Q, charge of electron. Alright, let's see what we get here on the calculator. 2.5 times 10 to the power of 6 times mass of the electron times 0.10 over the charge of an electron. 1.42 microvolts.
Yeah, explain the force particle.
Here,
Yep.
you're happy with F equals ma.
No.
You're not happy with F equals ma. But you just proved this like 2 weeks ago.
No, I don't know why is it got to do with what F thinks.
Hang on. Let's take it back. You are happy or unhappy that this is true?
Happy?
Okay. And so A equals F over M.
Why is there a force?
Huh? Why is there a force?
Yeah.
Because this is positive, this is negative, and this is an electron. And it wants to be pulled because it's in an electric field. So, it's a force. It's being pulled to the positive plate. The electric field. Yeah, so are you happy with this? Now, F we said is equal to QE. This is one of the formulas we've had for electric fields. And the E is equal to V over D. That was another formula we had in the electric field lesson. So what I've done is I have a formula for the A. So if I know the A, the Q, the M, and the D, I can get the V. And I can know the A from using UVATS. Quite hard.
Is it exam question?
Yep.
Oh shit.
I saw it now, in fairness, I did only see it once. Audrey, do you have a question?
Why are we looking at the electron and top?
Because I said in the question, my useful piece of information was the electron just about misses the top plate. So it means I know that the electron's maximum height will be the top plate. And this is the distance that I know, you see.
Lots
In misses.
Well, it's because I used the expression just about misses.
So it's still like 10
If you
million.
really want to be so, it could be something like this. Or, you know, if you really want to be particular.
There's no gravity for
There is gravity, but the gravity force is so small.
why?
Well, because the mass of the electron is so small. So if you did an mg, that force would be so tiny, it would barely add to this force. Like if you wanted to be particular, okay, I said A equals F due to the plates over M. But really, it should be F due to the plates plus the weight. Okay, but I know that this number compared to this number is so small that adding it on will have no effect to really, no effect really on the A.
In the beginning, we can use that the way.
If it was an electron, yeah, because its mass is so small that the force is dominated by the electric field. I think that's reasonable for the exam. Yeah. Is it good?
Lots of things to think.
Well, that is good.
We have to know the formula. We have to know our formula.
Yeah. Really sucks that, they expect you to know things for exams. It'd be so much easier, there wasn't an expectation to know things. Okay, can I close this? No, you're writing, that's okay.
UVACS, projectile tube,
Yeah,
electric field.
yeah.
There are lots of things.
I love it.
Yeah.
It's great.
Will they have like a lot of questions that combine everything together?
No, not really. Sometimes, not
This
really.
section
Be a
was
lot
B,
of
section B or
Section B, this was, yeah. Huh?
Should there be a lot of theory?
Look, what do you want from me? Like, what do you want in the exam?
Ask the guy who write the exam.
No, but what do you want in the
I
exam?
want theory.
You want theory. I
I
thought
don't
you
want-
didn't want
I
theory.
don't want theory.
What do you mean one theory?
So you want blah blah blah.
I don't want what?
You
Well,
don't
so
want.
what do you want?
Simple question.
Yeah, exactly.
Okay, I'm closing this now. Yeah. Right, so let me. We did this one. Okay, so let me just